Hi, welcome back. So we are at exceptions and errors section. The last outline to discuss is how to define our own exceptions. So far, we have seen number of those built-in exceptions. However, at some times we might need actually to interfere and come up to create our own customized type of exceptions. So here I'm going to introduce you generally to the main idea and the actual design structure if you wish to. And one interesting phrase related to that topic, which called ask forgiveness rather than permission, which is related to what we have learned in programming in general when it comes to create if-else statements. Let me take you back to our Visual Studio Code. The simplest way, of course, we have seen that most of the exception built-in classes are inheriting from this particular class, which is actually inheriting again from the exception base class that we discussed in the previous one, beside, of course, two more classes. So if we want to design our own customized exception method, the easiest one to do is to write a class and then extend or inherit from the exception class. Let's see an example. Let's define here a class and let's call it for a banking system kind of invalid withdraw, something like that. And of course here I'm going to extend the exceptions. This is the simplest way to start actually to think that I can now have my own exception. If I want to raise this one, you could see I'm using the raise keyword, and here I can just call in the invalid withdrawal. So this is, it clearly shows you the ability of to go and actually to do whatever you want. From here, given the fact of understanding inheritance, I can override some of those exceptions and build in functions, etc. Let's now go to the init. And of course, you could see now all this information should be clear. A super should be actually talking the init that comes from the parent class. But here, let me just put some amount. Let's say, for example, imbalance. Maybe to call the super function again, but this time I'm going to pass a certain sentence and could just in fact put that amount message. And in fact we could also assign like self.amount is equal to the amount and self.balance is equal to the balance. Now if I would have to raise invalid withdrawal, and it's of course he's going to ask about the amount of balance that we asked down there. Let's just pass 25 and maybe 75. Now if I run that, you will see that exceptions will be raised. The account has this amount, which is actually from the dunder init that come from the exception class. So this is a very powerful thing. That means I can do a lot of things from here. Maybe I could even write a new function here. Let's say defined whatever you called. I said, of course, going to take the self. And this function just will return the self.amount minus the self.balance, something like that. Why did I add this function? To show you that we are actually able now to use this kind of a class to handle a certain situation. Let's assume I'm going to now use the try, close, and let's here raise and invert exceptions, say for example 25 and 75, whatever that. And here I can add the except, a close if you remember. But here in particular, I'm gonna take the invalid withdrawal and not only in generic, but as a. Watch carefully now, we spoke about this as a syntax. I'm gonna print here a message, and then I could now go to E and dot. Now you could see I have access to the overage function here. What I'm trying to say here, in some cases, we actually the same work we can do with exceptions, we can do with the simple else if statements. Let me show you an example here. If I would have to define here a function, let's take num1, let's take num2, and let's try here. Now here I'm going to print number1 divided by number2. Of course, here I could add the except. And the only exceptions in this case, we don't want this to have zero division error. this function, clearly, let me just say that class is not needed anymore. This function clearly show you the use of exceptions as we have created. However, I'm going to do exactly the same thing as you can see here. This time, I'm going to make a check. If the num2 is equal to 0, I'm going to print a sentence code. So this is the condition, else I can do whatever I want, which is actually to print exactly this line that what I have done here. Now, the difference between this case and this case, this is where we use the exceptions and errors, standards and structures. Here we use the standard control flow of if-else condition. Now, both of them exactly will do the same job. So you might wonder, why would I go and bother to actually check the actual exceptions and error stuff? Because really, believe me, sometimes no matter how good your design of if and else statements, you might miss sometimes a little bit of details, and that can cause you a huge burden if the application is released. And by the way, as I have mentioned in the outlines, there's something called the ask forgiveness rather than permission. This is the actual idea of try and accept. So whatever we are trying to do, we will try to do. If an error occurred, the exception will take care of that. Either we can be very specific based on some built-in exceptions, or we create our own kind of exceptions and error handling classes. So we have come to end with this section about exceptions and error. You could see that in this section, I did not add any case study. However, there are tons of applications you can think of. In fact, one of them in particular, maybe if you would like to design a simple widget just for username and password control, with some kind of exception can be thrown if the password doesn't meet some standards. But we're going to move to section number 5, and that is to discuss about the use of object-oriented, when to use, and what kind of feasibility vision you must have. I will see you then.